Okay, so we're going to look at a few of these questions. There might be a lot of pauses in between, but I'll try to explain the gist of the functions. So this is the function f of n is equal to 16n squared, and the question is which of these values of c are upper bounds that show f of n is O of n squared. Now what this question is really asking is what value of c would show that the value of c is bigger than 16 of n squared. So what it's really looking for is what is going to be, let's start drawing this out. What is going to be the, pick a new one. Oh, that's not what I wanted actually. Let's delete this. I don't want a collection, I wanted a scene. Create a scene. What is this? This is nothing. I think I also don't want this. Oopsie daisy. Bear with me for a moment. Okay, let's create a scene. And we're gonna do okay. So what it's asking for is a f of n. I'll just type this out. F of n. And it's asking what value of c. So what value of c would show that this function is, this c function is bigger than the 16 n squared function. So f of n squared, so f of n currently, we'll call this g of n, because ultimately these are going to be two different functions. And f of n is currently 16n squared. So what it's really asking for is just what value of c is going to be bigger than f of n. So because 16 is bigger than 15 and 1.5, the answer is that neither of those solutions provide an answer to show that it's bounded. So all you're really looking for is what is the constant variable that's going to be bigger than 16 to show that this function is bigger than this function. And ultimately, since this function is bigger than this function, you know that it's bound by n squared. Like it can't be bigger than n squared. O of n can't be bigger than n squared because if c was 17, this would be bigger than 16 n squared, no matter what function, what value of n you give it. So that's the answer for that one. So I believe this one is just correct. You want to look at the biggest value of f of n, so you typically ignore 3n, so that will usually get crossed out, and you really just want to look at what's the biggest term in your polynomial function. So here, obviously n3 half, that's going to be the bigger value, and so we kind of default to O of n 3 halves. So these questions I kind of covered in my insertion sort video, but 4 I did not. So let's talk briefly about 4. So in the default case of our insertion sort, we swap in every instance, but there's some cases where we do redundant swaps where we're not actually, we're sorting unnecessarily. And we can stop that by implementing a guard clause. So let's take a quick look at the code. Oh, I actually didn't cover insertion sort, so I'll cover that at some point. Did I? Either way, it's not going to be in this video.